Hey guys, we're Team 1 for Petty 4998, and we're doing our presentation on Algiers Field, North Dakota, which is a field within Mountrail County in North Dakota, and we are doing our presentation on production optimization through recompletions. My name is Logan Roussel, and I'm joined by my colleagues.
I'm Kyle Kotelchek.
I'm David Gullett.
And I'm Easton Messina. We're all a part of team number 1 at Petty 4998, part of Dr. Williams' course. Today I'd like to talk to you guys about the production data in the Bakken field. In the Bakken field we have 3 different types of reservoirs. We have type 1, type 2, and type 3 reservoirs. The different types of reservoirs can help you plan out the production life of the well. It can help you estimate the original oil in place, what the economic limit of the well is, and if it's economically feasible to go in and recomplete the well and optimize production. During this point, you can look at things such as bubble point to figure out if you want to recomplete the well.
So with the Bakken Basin, we have a specific geography and lithology to it. The specific lithology of the Bakken play consists generally of shale, which is why that there's a lot of effort put into putting this process into order in order to produce from the formation, as it is a very tight shale with a lot of siltstone involved, which we will find that on a more technical level, the formation initially consists of a specific dolomitic sand or siltstone lithology, which is divided into 3 separate parts, consisting of 1, the upper organic rich black shale, 2, the middle silty dolostone to fine-grained sandstone, and 3, the lower organic rich blackstone. And you'll also notice that later in the presentation we'll talk about how both the upper and the lower formations affect the middle formation during production.
Companies can now analyze the production data of their fractures through their unconventional wells. You'll notice they can run data and basically look at the production analysis of each stage and cluster of their fracture of the well. Over time, with a lot of analysis, they can notice that the stages and clusters that are farther away from the tubing tend to have a lower efficiency of the frac. And they want to notice, they start to know that the stages and clusters that are beginning in the tubing have the hydrocarbon wants to favor flow towards those. And so companies can now, when they want to go to refrac and re-stimulate the well, they can reconfigure the fracture geometry of their well design to get the most out of their recompletion.
In fracture geometry, you're really looking at 2 different types of fractures: longitudinal fractures and transverse fractures. Longitudinal fractures are long fractures that extend through the reservoir and cover the most area possible. And transverse fractures kind of come out from one point and they kind of choke into that one point, and they don't cover as much as the reservoir as elsewhere. That's the reason why with new refracs we want as many fractures as possible to try to increase the permeability in those choke point zones. All right, so the upper and lower Bakken shale, the Bakken split into 3 different areas like we mentioned before: the upper and lower, which are both shales, and the middle, which is more of a sandstone dolomite mixture, which is the main focus of production. The upper and lower do contribute to production, just not as much as the middle member. That's the reason companies don't focus on them as much. But with the advancement in completion designs, the upper and lower members of the Bakken could be producible in the future.
So when analyzing the Bakken formation, we have to analyze economically both our EUR and our net present value, as we denote as NPV. So EUR is our enhanced ultimate recovery, which is essentially the main determining factor if a recompletion was beneficial or not. This tells a lot for companies that need to analyze if the recompletion was beneficial enough for that formation or not. And then the net present value, which is equally and probably even more important than the EUR in a sense, can be best defined as the sum of money in the present, which relates to the future value it will gain once it has been invested at a specific compound interest rate. And why NPV is important is basically because the money we have today and we invest in the Bakken today can eventually translate into more money for companies in the future. So if we're cognizant of all these facts and using simulations such as Monte Carlo and others to estimate our EUR and NPV, we can, as companies and different petroleum engineers, be much more efficient in our ways of producing from the Bakken and earning more money for our companies, which in turn drives up the revenue of our of oil and helps the company and the industry in general.
So in conclusion, using the previous production data, the lithology and the geometry of our fractures, and also the enhanced ultimate recovery techniques, we can optimize production in wells that have previously been produced in the Bakken field. Additionally, attached to this PowerPoint is our works cited, and in that works cited you can find URLs to all the links of the documents that we have used to find the information for this presentation. We thank you for taking the time to listen to this presentation, and just have a nice day.